similar to matplotlib, Seaborn library is considered as one of the most used library for creating visualization. In this video, we are going to see how to create industry standard visualizations using Seaborn library. Let's get started. So for doing all those things, the first thing what you have to do is we need to import the libraries. First, I'm importing Seaborn and matplotlib library into my coding environment. Then I'm setting the theme. What should be the theme that I'm expecting? So everything that I could fix it. So for here, what I'm saying is I am saying to create a grid that has a background of white color, and then I'm importing a data set. So the data set called tips data set. So it is actually a restaurant data set where most of the people will be visiting and they'll be paying their bills. So after paying the bills, they'll be giving tips, right? So it is a kind of data set like. See, this is how my data set is going to look like. The first chart that I'm going to create is star plot. Star plot is generally a combination of charts. If I want to understand my data in different angle, the one chart that I should use is pair plot. Using this chart, I can clearly understand the relationship between every numerical column. So you can compare two chart by two chart. I can understand how two columns are compared with another two columns. So in one big picture, I want to see all numbers in my data relate to each other. So in that scenario, I'll be using star plot. In my data set, what I have, what are all the numerical data? Total bill, tip and size. So for all these things, I'll be creating this star plot. Total bill, tip and size. These are all the numerical columns. See? So for all this, I'm creating this star plot. Now, look into the coding. The first thing I'm doing is sns.pairplot of tf. Here, what I'm doing is I'm calling my sns.pairplot library. I'm telling my Python create a pairplot. So it will be creating first, it will be creating scatterplots between numbers. Then when I give 2 is equal to 6, what I mean here, I am grouping by color. So for grouping by color, I am going to compare male and female there. So male should be in one color and female should be in another color. So what I'm telling is, show me the relationship, but tell me which points are male and which points are female. And then I'm giving the customization for creating the chart. Palette is equal to set1. So generally in set1 palette, I'll be having bright and clear color. So based on this chart, I could customize this. And when I give diagonal kind is equal to KD, it is actually diagonal. That is what I'm giving as DIAG encoding. So here it is used for showing the distribution of each numerical column. Here, the purpose of KDE is it is going to create a smooth curve which shows the density, how values are spread among. So it is actually a smooth version of histogram. And finally, when I give plot dot show, it will be showing my entire figure like this. See, all these three numerical columns are compared by creating three types of charts. The second chart that we are going to see is joint plot. What it is? Just look into the chart and can you understand what is going on? What it might be? What is the purpose of this chart? It is specifically used for understanding the relationship between x and y in the center. Distribution of x at the top and distribution of y at the right. So you can think it like this. Show how two things are related and how each one is spread. I want to see how two things are related and how each one is spread. So for this, I'll be using this chart. Now it's time to understand the coding. It is actually simple. First, I'm creating a joint plot, right? So I'm giving sns.jointplot. Then I'm giving data is equal to tf. I'm telling me Python coding to use the tips data set. That's what I'm giving here. Then when I give x equal to total bill, for x-axis, you are going to plot total bill. In the y-axis, you are going to take tip. So when I give this board, I am telling my Python to show how tip depends on total bill. And finally, when I give the colors equal to purple, it is going to create a chart with purple colors. And finally, when I give plot.show is equal to, like, when I give plot.show, the chart will be created like this. Then we do have Violin Plot. This is the third chart that we are going to see. See, it is called as violin chart because it looks exactly like violin. See how it looks. Now let's try to understand how it works first of all. Most of the people, by just looking into this chart, they will be scary of using this into their coding because they have a problem in understanding how it works. Let's see how it works first. First, look into the coding part. So this is my coding, right? Let me explain how the start works first and then let's go to coding. When it comes to violin plot, it tells you three things at once. How data is spread, where most values lie. It shows me the comparison between categories. The fat part here means many data points. The thin part here means few data points. The fat shape looks like a violin. So that's why we have the name as violin plot. Now it's time to look into the coding part. Violin plots coding. Okay. So here what we are doing, how it is created. It is as simple as how we created another chart. First thing is I'm giving sns.violin plot to create a violin plot. Then inside that bracket I'm giving x equal to day. So I'm telling the categories Thursday, Friday, Saturday and Sunday are all categories, right? So all these categories are plotted on x-axis. And in y-axis I'm giving total bill. So numeric values are being plotted on y-axis. And data is equal to dfy because I'm calling the tips data set here. And when I want to use a specific colors based on better visual appeal, I'm giving palette is equal to pastel 1. So here we'll be having the soft pastel colors. And finally, when I give plot dot show, the final output would be looking like this. Four different violins are connected together, which is colorful, but it is not actually a violin. So what this fat region says, most of the customers are giving this much of total bill. And this height is about the bill amount. The height is high, it says the total bill also is high. If the height is less here, the bill is also less. That's how you need to understand this. Then we have swarm plot. The name says how it would look, right? See, look into the chart and you can understand why we got this name. But what is exact difference between this swarm plot and that scatter plot we have seen? See, this is called a scatter plot, this particular plot. What is the difference between scatter plot and swarm plot? Do you know what might be the difference? The one big difference is the dots. The dots will not overlap each other. The dots will be unique and individual. It will not be overlapping at all. Now it's time to look into the coding part. So here in Violin plot, sorry, swarm plot. So in swarm plot, what you are doing here is every single data point is clearly visible. It is grouped by category and it is being spread out in a way the dots are individually visible. Now it's time to have a look into the coding part. Here, what you are doing at first thing, sns.swarm plot. Why? This is something I'm telling to my coding, create a swarm plot. Then I'm telling you plot the categories on x-axis. When I give x equal to day, when I give y equal to tip, numerical value should be on y-axis. And data equal to df because I'm calling the tip data set. Palette is equal to dot 2 because I am going to use a dark and high contrast colors here. And finally, when I give plot dot show, it will be showing my output. So here in this chart, each dot is representing one customer. Every dot which is equal to one customer. That is something that you need to remember. So no averaging, no hiding, raw truth. So in vertical position, higher dot means higher tip, lower dot means smaller tip. In horizontal spread, just to avoid overlap, does not mean any values. So when we need this kind of chart in real life, so if I want to compare which day has most customers, which day has highest tip values, are these outliers? I mean, very high tips. Are there any outliers or very high tips? Or tips consistent or scattered? To understand all these things, I'll be using Swampy. The final chart that we are going to see is something that not everyone will be using, but this is an important chart. This is a FacetGrid chart. See, this chart is specifically used for comparing the numerical values. Here, same graph is repeated many times, but split by categories. So here, each small group shows one subset of data. So you can think it this way. One big chart, which is being cut into small pieces. So each piece tells us a new story. Now have a look into the coding part. First, what I'm doing is I'm giving g is equal to sns.pairplot. So what is happening here? FacetGrid means creates an empty grid. No data drawn yet. Then I'm giving df. So data set used. It should be called here. Then when I give col is equal to time, I'm saying columns of grid means the time here. It is lunch or dinner value. It might be anything. In rows, I'm giving 6. So rows of grid is equal to 6 values. It might be male or female. So when I give height is equal to 4, this means the height of each small group. Bigger number means bigger plot. The second line is about drawing that plot. In each small box, draw a scatter plot of total bill versus tip. That is what I am telling here. Here, data is automatically filtered. Seaborn select correct subset. Same plot, logic applied everywhere. That is what is happening here. And finally, when I give plot.show, the output would be looking like this. So what is the purpose of this chart and how to read this grid? So by looking into this, can you understand anything? Yes, we can understand something partially, right? So how it works? The first step is you should read the headers. The top part is about lunch or dinner. The left part is about male or female. Then you are going to compare the inside rows. Male lunch versus male dinner. Female lunch versus female dinner. And finally comparing inside columns. Lunch male versus lunch female. Dinner male versus dinner female. So from this one plot you can easily answer, do people tip more on dinner? Do males or females tip differently? Is bill tip relation consistent everywhere? Is lunch spending different from dinner? All visually. We can easily understand. So this coding is going to create multiple scatter plots showing the relationship between total bill and tip, separated by meal time and gender. That is something you should keep in mind. You should specifically use this whenever you are comparing subgroups. You are doing deep analysis. You are teaching or presenting something. But you should avoid this when you are trying to understand the very simple data. When you have too many categories, because it will create so many plots. Yes. This is how the start specifically works. So what we learned for the day? We learned how to create 5 different charts using Seaborn and how that works. We have learned everything from scratch when it comes to coding and the purpose. So if you have any doubts, without hesitation, drop them in comments. Bye for now. We'll meet you in next amazing video. If you're watching my channel for the first time, make sure you subscribe my channel because you will not be missing any update. Because in this channel, I'm posting full AI course. And this video is a part of that beautiful course. Bye. We'll meet you in next amazing video.